Welcome students to the series of lectures on hypothesis testing. And in this series of lectures on hypothesis testing, now we have reached to step 2, which is defining your distribution. So we'll try to master the step 2 of hypothesis testing, that is defining your distribution. But first understand where we are in this journey. In the first session of this lecture, we discussed that to perform hypothesis testing properly, you must master 5 important steps of hypothesis testing. In the last session, we try to master, we try to understand in and out the step 1, which is defining the hypothesis, which means how you define your null hypothesis and how you define your alternate hypothesis. Now, in this session, what is our focus? Our focus is to move to step 2, that is defining your distribution, which simply means how to choose the right distribution. Why do we need distribution? When we perform hypothesis testing, we don't randomly decide the outcome. We compare the sample results with a probability distribution. And depending upon the scenario, we might use normal distribution in certain scenario. We might use t distribution in certain scenario. We might use chi-square distribution in certain scenario, and we might use f distribution in certain scenario. So by end of the session, you should be aware that which distribution to choose when you encounter certain scenario. Okay, so this is one of the most important skill or one of the most important step in hypothesis testing, which simply says that you must know which distribution to pick for which scenario for which hypothesis testing. And that is what exactly we are going to master in this session. And before we discuss which distribution to choose, we must understand one very subtle important concept in hypothesis testing. In hypothesis testing, whenever we use any distribution, whether it is normal t, chi-square, f distribution, we are not talking about population distribution. We are not talking about sample distribution. We are only talking about sampling distribution, not sample, sampling distribution. Not population, not sample, sampling distribution. This is extremely important. What is sampling distribution? Let's first understand intuitively. For example, assume you have a population, and from that population, assume this is the population, and this is the distribution of the population, this specific distribution of the population. From that population, you took a sample. You took a sample. Then you calculate the sample mean. Then you took another sample, you calculate sample mean. You took another sample, you calculate sample mean. If you keep on repeating this process, maybe sample 1 would be 52, sample 2 would be 48, sample 3 would be 51, sample 4 would be 49, sample 5 would be 52 again, sample 6 would be 48 again, so on and so forth. So each sample will give a different sample mean, or could be that it would be same sample mean. And if you plot the frequency or distribution or probability of all these sample mean, for example, you took the number 52, 51, 49, 48, and start plotting the frequency of their occurrence or the probability of these sample mean, that is called as sampling distribution. So what is sampling distribution? Sampling distribution is the distribution of the sample mean or the frequency of the sample mean, the plotting of the frequency of the sample mean, the plotting of the probability of the sample mean. Okay? So population distribution is the distribution of the population value. Sample distribution is the distribution of one sample. Sampling distribution is the distribution of sample statistics. And one of the sample statistics is sample mean. It could be variance, sample variance. And if you plot the sample variance, that will become sampling distribution of the sample statistics, that is variance. Perfect. And in hypothesis testing, we work with sampling distribution. And why sampling distribution is important? Why this concept was important? Because in hypothesis testing, we test what? We test the statistics of a sample because we will never know what the population would be. For example, the question would be like this: a portfolio manager claims that average monthly return of his strategy is 2%. Now, this is his claim. So, what is the claim? Claim is that the return of his strategy is equal to 2%. That is his claim. To verify the claim, an analyst collects a sample of 36 months of return and finds the sample mean return is 1.6%. So currently the sample mean return for this sample came to what? 1.6%, not 2. If you take another sample, it will come 3.6%. On an average, it is going to be 2. So basically what you're doing, we calculated sample mean. Then we check, is this sample mean significantly different from 2% or not? So what we are testing? We are testing the sample mean, which is what? Sample statistics. So whenever we test the sample, we must use what? Sampling distribution of the sample mean or sampling distribution of the sample statistics. And that is why sampling distribution becomes a very important concept. Now, which distribution to choose? Now, it is very simple because I'm giving you some simple rule. Case 1. If hypothesis testing revolves around sample mean, you will use normal distribution or t distribution. That's it. If you are testing mean, whether it is mean return, whether it is mean height, whether it is mean salary, if mean is in the question or mean in the scenario that you are testing, it is the sample mean that you're testing, you will use normal distribution or t distribution. If the hypothesis testing revolves around sample variance, I calculated the sample variance of Nifty, it came to 5%. I calculated the sample variance of Tata Steel stock return, it came to 2%. I calculated the sample variance of Indian household income that came to 20,000 rupees. Whenever the question is about sample variance, you will use chi-square distribution. If in the question it is sample variance, chi-square distribution. But in the question, if they say you have to compare the variance of two different entity, for example, they will say, okay, the variance of Nifty is 7% and variance of S&P 500 is 8%. Two different entity variance. If you're comparing, you will always use F distribution. So what is the summary? Sample mean, normal distribution or T distribution. Sample variance, chi-square distribution, ratio of two variance or the comparison of two variance, then F distribution. Now, normal versus t distribution. When to use normal, when to use t distribution. If you're testing sample mean, then should I go with normal or should I go with t distribution? The rule is if the population variance is known, the sigma symbol is for what? Population variance. If the population variance is known, you will use normal distribution. If the population variance is unknown, you will use t distribution. Or if the sample size is large, you will use normal distribution. If the sample size is small, 20, 25, less than 30, you will use t distribution. So use t distribution when population variance is unknown or sample size is small. So now you would say that, okay, at this stage, I haven't got a full understanding. Yes, you may. You may not fully understand why we choose these distribution. Right now, remember this as a rule of thumb. Remember this as a rule of thumb. As we move forward and start solving problem, the logic behind these distribution will come. The logic behind these distribution will become completely clear. My final thought for this session would be like every hypothesis test is based on sampling distribution of a statistics. Sampling distribution of a sample statistics. That sample statistics could be mean, that sample statistics could be variance. If you identify that sample statistics you're testing is mean variance or variance comparison, then you define which distribution or then you choose which distribution you will apply for hypothesis testing. Okay. So till now, in our series of lectures of hypothesis testing, we have completed how to define hypothesis testing, as in how will uh, write alternate hypothesis, how will write null hypothesis, and we have completed how to choose the correct distribution for the hypothesis testing. In the next step, which is step 3, we'll try to understand how to calculate the test statistics, and we'll start with normal distribution. With that, I'll pause here. Thank you. Have a nice day.